So yeah, what is the null hypothesis? Okay, so we start with question 10.9. It is asking that Miami Beach Tourist Agency claims that the percentage of days in the winter when the highest daily temperature exceeds 75 degrees is more than 80%. A random sample of 250 days reveals that in 212 days, the highest daily temperature exceeded 75 degrees. Can we infer at the 10% significance level that the tourist agency is correct? So what is here the null hypothesis? The null hypothesis is that the percentage of the warm days, days above 75 degrees in winter, is less than 80%, right? So which value for less than 80% do we assume? And then the alternative hypothesis is that the percentage of the days warmer than 75 degrees are above 80%. So alternative hypothesis is that P is larger than 80%. Because we do not need to calculate beta, the probability of type 2 error, and also because beta will not play any role in this question, we can stick with that as our alternative hypothesis. Simply, alternative hypothesis, percentage of days with high temperature is larger than 80%. We don't need to come up with any concrete value, like how many percent exactly, 81%, 85%, 90%, or whatever. So larger than 80% would suffice. However, for the null hypothesis, we need to assume a concrete value, right? So the null hypothesis is that it's not more than 80%, right? And we have to come up with a concrete value because we are dealing here with alpha. Alpha is 10%. So for the null hypothesis, when it's a range, like in this case, the range is from 0% all the way to 80%, right? That's our null hypothesis. For the range of null hypothesis, when we need to assume a concrete value, we have to always just take the value that's closest to the alternative hypothesis, right? So if the alternative hypothesis is more than 80% sunny days, for the null percent, we have to take the value in the range from null to 80% that's closest to more than 80%, which is what? Which is 80%. Right, so the null hypothesis is that P equals 80%. For the alternative hypothesis, things work differently. If we would have to assume a value, we just have to come up with an estimated guess. What is our best estimate? Okay, so for the alternative hypothesis, we would not, I repeat, we would not come up with the value that's closest to the null hypothesis, okay? So if you would have to, in this case, we don't have to, but if you would have to assume a value for alternative hypothesis, we would come up with whatever is our best estimate, 83%, 89%, whatever we would believe would be the case if it's larger than 80%. Now, that being said,
Professor?
Yeah.
Why isn't the null hypothesis the original argument, like P is greater than 80?
Because if someone comes up with a claim, we are always taking that claim usually as the alternative hypothesis, right? Essentially, usually the status quo is the null hypothesis, and whatever is not the status quo is the alternative hypothesis. Or if someone claims something, we take that as alternative hypothesis.
Yeah, that makes sense.
Yeah, kind of like the court case, right? I mean, the status quo or, you know, whatever is just like, okay, no one is a murderer, but someone comes and claims, okay, this guy is the murderer or whatever. A person has been arrested because of a murder, then, you know, that's the alternative hypothesis. Anyway, so essentially, I have here the sampling distribution for the null hypothesis of 80%. What is the next step that I need to do? The first step, I already did it here, is calculating what is my sample mean, and that is 84.8%. What is the next step? Oh yeah, what's our next step? Essentially, we are looking for an alpha significance level of 10%. It's a one-tailed test. If it's a one-tailed test and significance level is 10%, it means we don't need to divide the 10% by 2. In a one-tailed test, we just cut off the entire 10% from that tail that is significant. In this case, it's a right-tailed test. Why? Because alternative hypothesis is that it's larger than 80%, right? This is my alternative hypothesis, larger than 0.8. So if it's larger than 80%, it means it might be to the right of it, right? To the right of the null hypothesis. If the alternative hypothesis is to the right of the null hypothesis, we are dealing here with the right tail test, which means the 10%, we are cutting it off from the right tail, obviously, not from the left tail. Is that clear?
Yeah.
Okay, good. So that being said, next step is I use just this formula that we always use. So this is the formula that we use for binomial situations. This is a binomial situation, right? Either the day is sunny or it is not sunny, right? Our formula here is, as you know, p hat, and we use here the z-score, right? P hat minus p divided by square root of p times 1 minus p divided by n. All I need to do is just inserting the numbers. However, I have to pay attention to insert the right number in the right spot. So for example, for p, do I take the value for null hypothesis or alternative hypothesis? Obviously, the null hypothesis here, right? Because I'm dealing here with alpha. If I would deal here with beta, then I would take the p for the alternative hypothesis. Anyway, so for p hat, that's my sample mean. I insert the value 0.848. For p, I insert the value for null hypothesis, which is 0.8, divided by square root of, as I mentioned, for p, we take the 0.8 times 1 minus p, which is 1 minus 0.8, and then divided by n. N is the sample size. My sample size in this case is 250. 250. What I get is 1.9. My sample mean is 1.90 standard deviations to the right of the null hypothesis. Right now, the question is it to the right or is it to the left of the limit that we would set based on the 10% significance level, right? So is 1.9 to the right or to the left? There are two ways to answer this question. One way would be just looking up into the table and see 10%, how many standard deviations is it, right? So for that case, let me bring in again that table. So if I want to cut off the 10% tail, here as you see the value is on the left tail. I want to cut off 10% on the right tail, which means I have to look up the z-score for 90%, right? Because if to the left is 90%, it means to the right is 10% left. So I look up here the value for 90%, and it should be between 1.28 and 1.29. You see 1.28 is 0.8997 and 1.29 is 0.9015. It's much closer to 1.28 than it is to 1.29. So it means this limit is 1.28 standard deviations away. My sample mean is 1.9 standard deviations away, right? So my sample mean is to the right of that limit. It's 1.9 standard deviations away, which means that yes, I can claim with 10% significance level, which means with 90% confidence that at least 80% of the days in Miami Beach are hotter than 75 degrees Fahrenheit based on the sample that I took. There is a second way to do it. This one is more accurate. So now the second way to do it is calculating the p-value, because that is giving us even more information. Calculating the p-value is, now that we know we are 1.9 standard deviations away, we can just simply see 1.9 standard deviation, or more extreme, that would be as if I'm cutting off the tail at how many percent. So we can again look that up in the z-score. So instead of looking up for the alpha, the 10% thing, I just look up 1.9. 1.90 was what we had here, right? Look here, 1.90, and I look it up. 0.9713. 0.9713. Now, what is 0.9713? Is the area to the left. I'm interested in the area to the right. So it's 1 minus 0.9713, right? So I can write it essentially here, p-value, the probability that the z-score is 1.9 or larger, so essentially more extreme than 1.9, is 1 minus, what did we have, 0.9713, which is 0.0287 or something like that, yeah. Right, so essentially we can conclude that yes, that claim is true based on our sample, and the chance that we are wrong with our conclusion, so the chance of a type 1 error is how much? It's 2.87%, right? The value here, that's the chance that we are wrong, because that's our p-value, right? So 2.87%. Is that clear? Okay,